Sample Practice Prob for Honors Physics by Liz. A falling care package. An airplane moves horizontally with a constant velocity of 115 meters per second at an altitude of 1,050 meters. The plane releases a care package that falls to the ground along a curved trajectory. Ignoring air resistance, determine the time required for the package to hit the ground and the velocity just before the package hits the ground. Now that we have our problem, it's important to start by drawing a diagram. So here we have our airplane, and we have it in 3 different spots as it's flying in the air. And so right here, we have it initially before it releases the care package. So its velocity in the x direction is 115 meters per second. And then in the y direction, the care package hasn't been released yet, so it's still at 0 meters per second. Then at our next time interval, we see that it's still traveling at a constant velocity, because that was mentioned in the problem, of 115 meters per second. But we can see an increase right here in the y velocity, because the care package will be dropped. So the plane is still flying at the same height, but the package is dropping. So at our third time interval over here, we have the plane over here again. X velocity is still the same, 115 meters per second. And now we have, in the y direction, the distance of 1,050 meters. So that's how far it's falling down. So the next step in solving this problem is looking at our given information and writing it down. So we start off with the y at 0 meters because it hasn't been dropped yet, and then at the end it's at negative 1,050 meters, and it's negative because it's falling down. Now it isn't meters per second because that isn't a velocity, that's just the distance. We're going to calculate the velocity later, but now we're just writing down what we know. So when you look at the velocity in the x direction, it starts off at 115 meters per second, and so that's the initial. And also the final is also 115 meters per second. Now the time, we don't know, so that's why there's a big question mark there. In the acceleration, in the problem it mentioned that there's no air resistance, so we're going to assume that it is falling in free fall, which makes this negative 9.8 meters per second squared. Next, you just have to write down the equation and plug it in. So we have our equation to solve for time, which is y equals the initial velocity times the time plus 1/2 the acceleration times time squared. So remember from our given information, y equals negative 1,050. Our initial velocity was 0 times the time, which we don't know, so that we're just going to leave that as t, plus 1/2 acceleration, negative 9.8, and we don't know the time, so we're going to leave that as t squared. Then you just follow the steps of algebra to solve for time. So over here we see that simplifying this, because that becomes 0, that is negative 4.9 t squared, dividing by negative 4.9, we have t squared equals 214.29, and then to find just t, we have to square root both sides, and we find t equals 14.64 seconds. But the problem was asking more than just finding the time, so now we have to go solve for the other portion of the problem. Now it's time to find velocity. So it's important to draw a diagram again, so I took a little section from our previous diagram and just as if we zoomed in on that one section. So over here we have Vx at 115 meters per second, and we don't know what Vy is initially, like we're not told that in the given information, and we don't know the resultant velocity, and that's what we're trying to solve for right here. And that also creates an angle right here, which we're going to call theta. So the first step in order to find the resultant velocity is that we need to find the velocity in the y direction. So in order to do that, we can plug that into the equation acceleration equals final velocity minus initial velocity over the change in time. That's what delta t means. So we plug in negative 9.8 for acceleration. We don't know that velocity there, but we know the initial was 0. And we have the time that we just found, 14.6 seconds, that we found in the previous part of the problem. And then when you solve that, just do the algebra and multiply negative 9.8 times 14.6. You get that the velocity in the y direction is negative 143 meters per second. So you can write that in over here, that we know now, that is negative 143 meters per second. Now that we have both of those components figured out, we can use the Pythagorean theorem to solve for the resultant velocity. So over here we have vx squared plus vy squared equals the resultant velocity squared. Plugging in the numbers we found, 115 squared plus negative 143 squared equals resultant velocity squared. So when you do that math out, it turns out to be 33,674 equals v squared. Square rooting both sides, you get velocity is 184 meters per second. But we are not done yet because velocity is a vector, which means that it is direction as well. So that means it happens at an angle over here, which we call theta. So the easiest way to find this is you can use SOHCAHTOA, whichever way you want, because now you have all three components of this triangle. So I use the cosine of theta equals 115 over 184, because that's alternate over hypotenuse. And that results in getting a 51.3 degree angle. So now we have found all parts of the problem that it was asking. So we found the time, 14.6 seconds, the velocity of 184 meters per second, and the angle of 51.3 degrees. In summary, an easy way to solve all problems is just to draw a diagram, write down your given information, write the equation, and plug it in, which is just what we did here, and you'll always come to the right answer. Best of luck in all your problem-solving adventures. Alright, so in summary, the way to solve all physics problems, you just draw a diagram, write down your given information, write down your equation, and then plug it in. It's that simple. Best of luck in all of your problem-solving adventures.